So on page 2, the first part says express the relation shown in each set of ordered pairs. Okay, so we have a mapping diagram. We want to show this as ordered pairs. So let's open our squiggly brackets, and we're writing a set of ordered pairs. So the first ordered pair is what? -5, comma, 6. And then we have to put a comma between our ordered pairs, so there's a lot of commas and a lot of parentheses here. So let's list the second ordered pair. -4 to 9. Great. And the third ordered pair, 2 to 1. And the last ordered pair, 3 to 9. And then close your squiggly brackets. Joey, do you need a pencil? Okay. All right. So I've taken this mapping diagram and I've listed it as ordered pairs. So list each as a set of ordered pairs. On your homework, I give you like a little section to write that in. For part B, let's open our squiggly brackets and our first ordered pair. When I have graphs on a coordinate plane here, I typically go left to right. I could list these in any order, but for me, I like to go left to right so I make sure I don't forget any. So I'm going to start scanning through and I see my first points here. If this is my origin, I went left 2, down 1. So -2, comma, -1. Then my second ordered pair, scanning, I see is here. What's that ordered pair? -1, 3. Left 1, up 3. Good. Then my next ordered pair is here. So right 1, up 4, 1, 4. And my last ordered pair is right here. So right to 4, down 2. 4, comma, -2. It's my last ordered pair, so I'm going to close the set off saying all of these go together with the squiggly bracket. All right, it's just called a bracket, so. Questions? Okay, so these are all relations. Everything that we've shown you is a relation. There is a relationship between those points. They go together somehow. Okay, now we can say a relation could also possibly be a function. So we've seen functions. When we have y equals 2x plus 1, that's a function. We've been doing it for months now. The only thing I'm going to change is instead of saying y right there, you're going to see f parentheses x. That's function notation. So it's 2x plus 1. That's a function. The function's name is f. This part of my function is the 2x plus 1. It's defining what I have. So today our task is not too much of the function notation stuff. We will get into that. But today we have to decide if I'm given one of these things, can I decide if it's a function or not? And here's how I do that. A function is for every input, our x values, there's exactly one output. For every input, there's exactly one output. So if I'm looking at, ways to prove a relation is a function. If I'm looking at a table, so our XY table, this here, it is a function if my x's do not repeat. So do my x's repeat here? No, so this would be considered a function. So table is our focus on x does not repeat. The next piece is mapping. So if I had an x repeating, so like if I had 2 of these negative 2's, what would happen? How many arrows would I end up having coming off of that? I would have had 2 arrows coming off of it. So what makes a function by looking at the mapping diagram is that your x's only have 1 arrow coming off of it. So for our mapping, x has only 1 arrow. Each. So each x has only 1 arrow. And the last one, if I'm looking at the graph, I'm going to use something called the vertical line test. So I'm going to draw a vertical line, and it's not going to pass through my figure more than twice. So no 2 points on a vertical line. What's a vertical line look like? Straight up and down like this. It'll make a little bit more sense once we put it into practice. Okay, so in this next section, we're just going to determine, is it a function or not? Okay, they're all relations. They all have relationships between the ordered pairs, but we're defining, is it a function? If it's not a function, we're going to circle what makes it not a function. There's a section on your homework like this. So we have a mapping diagram. So our focus is that the x only has 1 arrow. So each of these x's, do any of them have 2 arrows coming off of it? Nope. So yes, it's a function. B, another mapping diagram. Do any of these x's, our domain, have more than 1 arrow? Yes, right here. This 4 has 2 arrows coming off of it, which means 4 is repeating. There's the ordered pair of 4, 5, and 4, 6. So this would be not a function. Because 4 has 2 outputs. Okay. The next one, if I drew a vertical line anywhere on this, would it touch the shape twice? I'm trying to think of what I have that I could say is vertical. So if I took this paper, here's my vertical, article, 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 4, and I draw this arrow to 1, this arrow to 5. How can I make this not a function? Draw the line from the 1 to the 4. Good. I could have said 2 to 4 or 2 to anything else, really. Not a function because that 1 is repeating. Okay, this one's a little tricky. So some equations are functions. So f of x is just like saying y. We have a squared, so 1/2 squared minus 1. We could do the y equals, what did I say earlier, 2x plus 1. That's a function. It could say f of x equals 2x plus 1. That's a function. It's a straight line, right? We did that all last unit. Some things that are not functions. It cannot be y equals a square root of x. Okay? Cannot be that. So if we saw that square root there, not a function. It cannot be x equals any number, because that would be a straight vertical line, straight up and down. And it can't be x equals y squared. That's again x equals something. Cannot be that. What that would look like is this U-shaped thing on its side. So it would look like this, which would be not a function. Questions?